So let's go ahead and talk about our attitude control system here in the Mercury spacecraft. There's a few things to note about the Mercury spacecraft. There's two sort of automatic systems, which are, one of them is automatic and one of them is semi-not. And then there are use of the horizon scanners. So much like in Gemini, there's horizon scanners, but if you're watching this, you probably haven't gotten that far. Mercury's systems are a little interesting. There are several control backups, offering a wide range of possibilities in terms of firing jets and how different systems are behaving with attitude control. It's a flexibility that, quite frankly, I really wish was in Gemini sometimes. So let's talk about the ASCS first. The ASCS has a couple of different modes. It's got attitude hold mode, it's got align mode, and it's got orientation mode. So when we drift a little bit, so let's go ahead and time accelerate. When we drift a little bit, we'll hit a dead band and we'll enter the orientation mode. With this mode, the system will automatically refix our attitude upon our desired setting. Here we can see we have it actually set to the re-entry setting, just for the simplicity of being able to see 000 for the purposes of the tutorial. In align mode, if we were to say significantly drift out of this orientation, the horizon scanners would no longer be sighting the horizon, and at that point the gyros will switch from normal to free, and the ASCS will switch from orientation or hold mode into align mode. And this happens automatically. We don't need to manually switch the gyros to free or anything. This will all happen automatically. So for example, let's go ahead and yaw 180 degrees on direct. We can see the horizon scanner has, you know, about, if I remember correctly, should be about like a 30-degree viewing angle. And then, it's probably like 25. And then we come around and we automatically hit gyro norm. We yaw 180, or we automatically hit gyro free, that is. We can yaw 180 and be pointed the other way. Now let's say we pitch around for whatever reason. Since we're in gyro free, we can see, whoop, the needles just did that sort of thing. So you can see when we do the gyro free, and then all of a sudden we get view of the horizon in one of those scanners. There are two scanners. All of a sudden these needles will just sort of flip around, matching that horizon scanner orientation. Of course, with yaw 180 degrees, we don't see that flip in the yaw 180 maneuver, and that is just simply because we've got ourselves acquired on a roll scanner. So there's two scanners here that are detecting black body radiation from the Earth, which is not emitted by space. We've got a roll scanner, so we can roll to no longer face the scanner towards the Earth. And we've got ourselves a pitch scanner, so we can go ahead and get ourselves facing away from the horizon yet again. And we can see now that we're in sort of this funny orientation, whenever we maneuver, we have an effect on many of our needles, even if we're not directly affecting those axes, and that is a result of the horizon scanner slipping from norm to free and back to norm. So in align mode now, if we go ahead and we reactivate the ASCS, the computer or rather the ASCS, will automatically use the IMU's reference to align the spacecraft here towards an attitude which acquires the horizon scanner. So we could see it's going to fix roll and then yaw in hopes of acquiring. We could see we didn't just quite get it yet, so we're going to go ahead and fix that yaw and that roll, and we should have that now on roll, and now we have that on pitch. So we've got the roll horizon scanner and the pitch horizon scanner in sight of the black body radiation. Now we'll talk about fly-by-wire. Fly-by-wire is a fully manual control system. However, it is not a cable-operated system like manual propulsion. It will drain the automatic tank. And if you didn't know, any commands issued by the ASCS or the RSCS, which we'll talk about later, will drain from the auto tank. Fly-by-wire is sort of that ASCS mode, but completely manually and direct as well. We could see it will not limit our rates, and it will not stop us from drifting. And we can see as we thrust, we are draining from that auto tank there. So fly-by-wire and norm are usually the easiest for people to understand. But there's a couple other cool things if you can get the handle on manual propulsion, which is a cable-operated system. With manual propulsion, we can actually superimpose a little bit of our RSCS offered to us through the general ASCS system, and we can superimpose those controls. So if we pull it out like this, pull for direct, and we switch this to rate command, and we switch this to aux on, we're on full manual propulsion via cabling through the hand controller. And if we push this handle in, now all of a sudden we've got some RSCS control. We're superimposing a little bit of that digitalness upon our cabling. So here we can see we can pitch up, and after a while the jets stop firing and we maintain a pitch rate. And when we let go, we can see that pitch rate begins to stabilize. If we take RSCS to full auto, we can see that it will stabilize down to near zero. At this point, the correct procedure here would be to go fly-by-wire, give that a tap, and go back to aux on. And check this out. If we go direct, and we do fire all of our thrusters, we'll accumulate some rates, and we push this handle in, and we go RSCS back to auto. We could see with RSCS on rate command, we were draining from the manual tank. So we'll go ahead and show that off. We'll let go. We can see drain from the manual tank. But with RSCS to auto, and it stabilizes, we could see actual drain instead from the auto tank. There's something to keep in mind. And the last thing that we can point out is that, in norm, we will get driving automatically to our horizon scanners. But if we set this mode to free, and we sustain operation on free, we'll be able to see that one axis isn't really going to affect another as we're flying. However, we will over time accumulate drift in the free axes. So sort of to stabilize this out and get rid of this drift, we want to do the best we can of aligning to 0, 0, 0. So we'll go ahead and we'll enter rate control here, rate command, and we'll try to get the horizon lined up as best we can with the mark on 0, 0, 0. This could be a little bit difficult to achieve by the window, so I like to use the periscope here. I think the periscope is sort of a much nicer way of doing things here. We can get fixed up on 0, 0, 0, and we can throw this to cage and then back to free. So I'll show you what that does by dramatically changing our attitude to be, you know, significantly off. Here, we're on free, and if we cage and go back to free, now we can measure a drift from this new orientation, which was the 30-degree heads up. So thrusting down back to the Earth and centering that in the 0-degree mark, we should see about a 30-degree pitch down orientation. So super useful for when you're measuring your attitude from other attitudes. And of course, switching back to norm, we see an automatic snapping to the horizon scanners, and the gyros will be torqued to compensate. So switching back to free, we no longer have that previous orientation we had when we caged the gyros. So let's say, for example, we wanted to sort of memorize yaw 30 here, and I don't know, pitch down a 30. We could sort of have that memorized, and we can cage the gyro. And now when we go back, we can see going back to this orientation, and we've got ourselves acquired a little bit of drift and roll, probably because we drifted out as I caged the gyros. Flipping back to norm, let's say we wanted to you know, let's say you were a little bit confused by like the retrograde orientation or something. You want to basically memorize that. So we'll go free, we'll cage, we'll go back to free, and now our retrograde orientation's at 0, 0, 0. So we can go ahead and, you know, do whatever maneuvering we want to. Maneuver out, and then we can go ahead and recenter our roll, our yaw, and then pitch back down to 0, 0, 0. And we can see here that now if we switch this back to norm, this will snap right to the retro attitude, as we are pointing directly at the retro attitude now. So I hope that that helps. It's just a little bit of an overview of the various control systems here offered by the Mercury spacecraft. And actually, wait, there is something I did forget to cover real quick. In ASCS, you cannot control your attitude at all. In full ASCS, this is a lockout. Just in case, say, you bump the handle, you don't want those jets firing and then having to waste all your auto fuel. So cool thing is we can pull this manual handle out and pull another handle out, and now we have full control of that axis. The spacecraft will do its best to hold our attitude on yaw and pitch, and we're given full authority over the roll axes. And this works for every single axis. We can do that on roll, and we can plug that back in. And of course we could do that, say, on yaw. Now we're able to yaw out. We can plug yaw back in, and we can see that the spacecraft will begin to realign now. And then we can also pull out pitch and say, no, I don't want you to have control of pitch. So we can see with pitch pulled out, we still get alignment on our yaw and our roll. And now we have full pitch authority to do, you know, whatever we needed to. So this is a really good way of operating if you're in VR and you want to say like yaw 180 degrees. And And because VR, if you don't have your own flight stick and you use the virtual one in the cockpit, because that could be a little bit touchy, you get multi-axis jet firing and wasted fuel. So this is a very, very good way of being able to maneuver in VR without wasting, you know, fuel by firing multiple axes because your wrist is a slight millimeter off. So really good system there. And I definitely wish that that was afforded in Gemini. And of course, it is an option in Apollo, which requires a significant amount more setup, but we could talk about that later. And that is everything actually that I did want to cover. Sorry, I forgot about, you know, one of the most important features for VR, being able to single axis fire jets. So hope that helps. Thank you.